In this video, I'm going to document zero crossing, both in Max MSP, an object abstraction I wrote, as well as a Juice VST plugin. And I'm going to compare it to the Timbre ID object in Pure Data zero crossing. So I'm going to start with Max MSP, my zero crossing object, which takes a file, and this is going to be the file that I'm going to be using of vocal recording of my friend Samira. So that's the recording. So we're just going to be counting based upon X number of samples or a wavetable, simply a number of times the waveform crosses 0 in that window. So the sound file is going to be coming into my abstraction and output the number of zero crossings in here. And so in Max MSP, basically it's a poor frequency tracker, but just basically also showing how much noise is contained within a signal. So here it is in Pure Data. What I found in Timbre ID is that it actually outputs a tenth. It's really more crude in terms of the outputting number. So in this case, I have 2048 as my bin length, and my window size here, the bin is 2048. So Timbre ID actually outputs this number, and I had to multiply it by 10 to get it to equate to what I'm the frequency tracking, the zero crossing rate that I'm getting in Max MSP. So that's roughly kind of a crude number. We can see it's between 1,000, 1,300, and then going below to about 800 in terms of its rate, zero crossing rate, and in here, roughly the same, without barring me printing these and looking at them. I already know, because I have to multiply by 10 to get a similar number, and it's outputting ints, that this is much more crude than what I've got going on here, but it does seem to be matching up to the eye. Jumping over to my VST object, zero crossing. So my window size set to 2048, but the update rate is a little bit slower. But very similar to what we were getting here. It's just counting the number of times the waveform crosses 0 within a given window size. The other thing that I wanted to do, at least in Juice, was to take this and output MIDI. So in this, it is spitting out MIDI. I can transpose that and quantize it. So if it's not quantized, it's spitting out at the rate of the window, which is pretty fast. This window, it's about 21 milliseconds at 44.1K, which is really fast for a MIDI note on message. If I mute the voice, we can just hear the MIDI output driving the synth. Now if I quantize the MIDI output, I'm quantizing it based so that every 750 milliseconds, then it's outputting whatever this frequency is. So it's not fully quantized so that it happens exactly at the same time every time, and depending on the number of zero crossings, you'll get sometimes a variant, so it won't be exact pitch every single time, which is kind of nice. So taking that, I'll go ahead and mute it, and we'll loop this. And we'll go ahead and add in another. This is happening, same window rate, but now outputting at 500 milliseconds. There's this one outputting at every 1500 seconds and driving a little bit of a different synth. Kind of fun. So this is a VST plugin that is taking the poor frequency tracker of ZeroXing and using it to drive a MIDI synthesizer inside of Reaper. But both objects are doing what this timbre ID object ZeroXing, which is just taking a simple way to measure a signal's noisiness to count the number of times it crosses zero in a given window.